Every year, a tremendous amount of water moves between the continents and the ocean, enough to cause the entire ocean to fall and then rise again by an average of 1.7 centimetres. That might not sound a lot, but it's enough to fill nearly 2.5 billion Olympic swimming pools. These images from NASA show an example of water being stored on the continents of the Northern Hemisphere as snow cover builds during the winter. The dark disk centred on the North Pole indicates when no sunlight is available, and so images cannot be recorded. Water moves because it is constantly being evaporated from the ocean, with the resulting precipitation falling back into the oceans and onto the land. While most of the water falling on the continents finds its way back into the oceans, some is stored as snow during the Northern Hemisphere's winter months. Some river basins, such as the Amazon, store a huge amount of water during their wet season. Eventually, though, the water makes its way back to the ocean as the snow melts, or in the case of tropical river basins, when the dry season returns. As water leaves the ocean during this annual cycle, sea level all around the world does not drop by the same amount. This animation shows a profile of a continent adjoining an ocean. On the left is a large river basin. As the ocean loses water and the river basin gains it, the weight of the extra water causes the land to sink. The increasing gravity from the filling basin causes water in the ocean to be attracted to it, causing the sea surface to rise. The net effect of both the land sinking and the surface being pulled up is that the sea level appears to increase close to the continent. The water moving from the ocean to the river basin causes average sea level to decrease, but far away sea level must be going down by more than the average because the level close by is higher. The opposite happens when water leaves the continents, for instance, when the snow of a glacier melts, shown here on the left. As the water mass leaves the glacier, the land rebounds. Less mass in the glacier means less gravity, and the water in the ocean that was pulled up next to it flows away. Sea level next to the glacier drops, but far away it will rise by more than the global average. Annual sea level change is shown here. The day of the year is displayed at the bottom, starting on January the 1st. The animation shows how these processes cause an annual sea level change that varies around the globe. The ocean levels are dropping, becoming more blue, as more and more water is stored on land. Minimum sea level occurs around the start of April, and then it begins to rise again, reaching the maximum around the start of October. But there are large regional differences. The most water is in the ocean around the start of October. The rise in sea level around North America and Northern Europe is much less than in other places. The land uplift and reduced gravity effect counter the increased water in the ocean, and so the change is much smaller along these coasts. In contrast, the amount of water storage in Bangladesh is near its maximum. The greater amount of water in the ocean, coupled with the land subsidence and increased gravity due to the water stored in river basins, lead to a change in sea level here of nearly twice the global average. Measuring how mass is distributed is the ideal way to determine the sea level changes we have discussed here. We measure this either by using satellites which orbit the Earth to sense the change in gravity as mass moves from place to place, or by using bottom pressure recorders placed on the ocean floor. Sea levels at our coasts are constantly changing, but the changes aren't the same everywhere. Data from around the world inform us how people in different places have different observations of sea level, even if this is caused by just one process such as the annual exchange of mass between the oceans and the continents.